Is it working? Yeah. Okay. So yesterday we said that when you have the roots of a quadratic equation, then we can find the relationship between them and the coefficient of the equation. Okay, and then we prove that if alpha and beta are the roots or solution for that equation, then when you plus them together, then the answer is going to be minus b on a. But if you multiply them, then the answer is going to be c on a. Okay, that's what we established, and then we prove that in two different ways. Remember? Okay. In the same way, for a cubic, we're going to say if alpha, beta, and gamma are the roots of this equation. Can you see that this is a cubic equation now? We can show that alpha plus beta plus gamma is equal to minus b on a. Okay, so when you plus them all together, the answer is going to be minus b on a. If you multiply them two at a time, then you're going to have that the answer is going to be, and plus them, then you're going to have that the answer is c on a. And if you multiply them, then the answer is going to be minus d on a. Now, can you see any pattern in here?
Yes. All over A.
All over A, and then can you see that they go in alphabetical order? So you go A, B, C, and D. And can you see that it alternate, negative, positive, negative, and if you keep going, it will keep the same pattern. And A will be always the denominator. All right. We can easily prove this. We're not going to do it because it's long, okay? And the proof is in the textbook, and it's equally done to that one. Remember that I did the proof for this in two different ways? Okay, so to do this, you do it in the second way I did this one. Okay, so maybe in tutoring or some other time we can do that. Okay, so we have this, and then have a look at that one. So this is a quartic. Okay, when you have a quartic, then you're going to have, obviously, we expect to have 4 roots or 4 solutions, or 4 places where the curve crosses the x-axis, all right? Okay, so we're going to call them alpha, beta, gamma, and delta. Okay, so alpha, beta, gamma, and delta. Make sure when you do this in test, make sure that you don't mix up this one with that one, okay? Because sometimes when you write this in test, they look the same and you mean something different, or you mean the opposite. So you've got to be careful when writing those little, Greek characters. Okay, so in here we're saying we can also show that if alpha, beta, gamma, and delta are the roots of this long equation, then we can prove that when you add them all together, then the answer is going to be minus b on a, which is always, the first part. Can you see that the addition is always the same? Mm-hmm. When you add them together, when you multiply them in pairs, can you see that in here we take 2 at a time? Okay, so when you do that, then the answer is going to be c on a. If you take them 3 at a time, then the answer is going to be minus d on a. And if you multiply them all together, the answer is going to be, that divided by that. All right? And then you can see that this is negative, positive, negative, and positive. Okay, can you see the pattern? All right, now, when you do this, when you do these things, well, the first one is going to be alpha, beta, gamma, and delta, so you add them all together. To get that one, you do this and this, this and this, this and this, this and this, this, and then this and that, all right? Okay, and then if you do that one, well, this and this and this, this and this and this, and so on. Okay, so you can create your own system to generate them. Okay, but you have to have all of them. Okay, so we're gonna apply this to some question. By the way, we use this to create equation with a given condition. So let's say that I want to create a quadratic equation and I want the roots to be equal to 2 and negative 3. Okay, so then I can use this stuff and create the equation very, very easy. Okay, that's what we normally do in tests. Okay, so if I want to have a nice solution, then I can create the equation very, very easily. Okay, but let's do some question, some application. All right, so I'm gonna delete this one here to give me some space, and we're gonna do some application of this. Okay, we're gonna say application. Application. We're going to say this. Number one, if alpha, comma, beta, and gamma.
Are we writing?
Yes, so now you're going to write all this. Are the roots of 2x cubed minus 6x squared plus x plus 2 equal 0. We are going to find the value of, okay, so I alpha plus beta plus gamma, B alpha beta plus alpha gamma plus beta gamma, C alpha beta gamma, and D we're going to find alpha minus 1, beta minus 1, and delta minus 1. Sorry, gamma minus 1. Okay, so we're going to find all those expressions, so we are going to evaluate them. I reckon that you shouldn't have any difficulty to find A, B, and C. Okay, but you need to see how you're going to find the answer for D. Most of the time, you're going to be asked to find what we know already. Okay, and then in addition to that, you're going to find something a little bit different, but it will be related to the previous solution. Okay, so you're going to change color. Okay, so you're going to use the same space to find the answer. All right, so the first one, we know that alpha plus beta plus gamma is going to be equal to minus b on a, because, well, that is the first one always. So it's going to be minus b. So you've got to be careful when doing this, okay, because this is minus 6. So I mean that minus 6 is going to be positive 6, okay, and then divided by 2, so it's going to be positive 3. All right? Got that? Yes? Okay. And then the next one, when you take them 2 at a time and plus them together, then the answer is going to be positive C on A. Okay, so this is A, B, C, so it's going to be 1 over 2. Right? And then when you multiply them together, then the answer is negative D on A. So it's going to be negative 2 divided by 2, so it's going to be negative 1. All right? That's it. Can you see that when you see this thing the first time, it looks very, very mathematical and very abstract and complex, if you like. But when you start doing, the question, then the whole thing makes sense, and you realize that all we're doing is just substituting. Okay, doing a little bit of algebra, but that's it. Okay, because there are a lot of people that get scared, very, very scared about seeing this symbol. But yeah, at the end it's just algebra. Okay, so to do the last question, we need to remove the bracket. So we're going to expand this. Okay, so that is the only way that we can do that. We're going to remove the bracket, And then we're going to reorganize the expression until we can use some of these previous results. All right? Okay, so let's do that. All right, so I'm going to multiply the first and then the first two, and then I'm going to multiply the answer by the other one. So if you multiply this by this, it's going to be alpha, beta, and then minus alpha minus beta plus 1. And I'm going to multiply that by gamma minus 1. Okay, so we're going to do the same thing. So we're going to have alpha, beta, gamma. And then we're going to have minus alpha, gamma. And then minus alpha, beta. And then plus alpha. Gamma, sorry. Now we're going to multiply the big bracket by -1, so we're going to have minus alpha beta, and then we're going to have plus alpha plus beta, and then minus 1. Right? I didn't make any mistake. Okay, so you can see that we have alpha, beta, and gamma by themselves. So can you see that we have alpha, beta, and gamma? And also you can see that we have the multiplication of them. And then we also have this line here. Okay, when you take them two at a time, but you have to take the negative out. Okay, so what I'm saying is this. So in here we have this is the same as alpha plus beta plus gamma. All right, so that. Okay, and then can you see that in here we have a negative, negative, and negative in front of basically that thing? Okay, so you're going to put negative as a common factor, and then we're going to have alpha, beta, plus alpha, gamma, and then beta, gamma, like that. And also we have the product, alpha, beta, gamma, and then minus 1. All right. Okay, now it's really, really good. Okay, really, really good, because we know the answer for this, we know the answer for this, and we know the answer for that, right? Okay, so be aware that there are a lot of questions in which you're going to have to manipulate the expression until you can use some of these or some other stuff that you can find. Okay, so then the answer is going to be, well, this is 3 minus a half, then minus 1, and then minus 1. Right, so the final answer is 1/2. Thanks, Amelia. Right. You okay with this question? Yeah? See, it's not a big deal. Okay, let's do another one. Okay, the next question says this. So this is question 2, or example 2. If x cubed minus 5x squared plus 7x plus k equals 0 has a double double root, find k. All right, that is what they say. When they say that they have a double root, it means that you're going to have, let's say when you solve this equation, you're going to have x equal 3 and x equal 3, for example. Okay, that's what we mean by having a double root. Okay, and also we know that this is a cubic, so that means that we expect to have, alpha, beta, and gamma. Okay, so that means that let's say that we have alpha, and then beta is equal to alpha, so we can write the roots of this. We can write that as alpha, comma, beta. All right, do you understand? Or you can do alpha, gamma. It's the same thing, as long as we have two equal. All right? Okay, so we're going to say solution. Okay, keep in mind that we need to find the value of the constant. All right, so we need to find the value of k. How are we going to do this? You're going to say this. So we're going to say let alpha, alpha. If you want, you can say comma gamma be the roots of the equation. All right, so we're going to say let alpha, gamma be the roots of the equation.
Right, I still don't understand the double root thing. Is that just like when we're doing cubic things and we had like, let's say -1 and then -1 and then like 3?
Yeah.
That, okay.
Yeah.
Does it have to do with like the multiplicity of the factor? Like, because the root, didn't you say like double root was like if it was squared you have to, right?
Yeah, so in here, we don't need to make this harder than what it is. Okay, so what I'm saying is, in here, all what we're saying that when you solve this equation, two of the solution will be the same. That's all what we're saying. Okay, for example, let's pretend that the solution are, 2, and then you got 3, and then you have another 2. That's it. That's all what we're saying. Okay, and then, well, using this, we're going to try to find the answer for the constant. That's what we're doing. So that's why in here I say let alpha and gamma be the roots. Can you see that I should say alpha, beta, gamma? Okay, but we know that two of them are the same, so I say alpha and alpha, right? Okay. And then we're going to use this to find the answer for k, right? Okay, so then we're going to say, so we know that when we add these three things together, the answer is going to be equal to 5, okay, because it's going to be minus b on a. Okay, so we're going to say, so I'm going to label this alpha plus gamma have to be equal to minus b on a, okay, and this is -5, so it's going to be minus 5 divided by 1, so it's 5, all right, okay. Also we have, and I show you that sometimes you don't need to use all of them. Sometimes you need to use that one and that one, or that one and that one, two at a time. Okay, but we're going to write it down. Also, we know that when you put them together, okay, in pairs of 2, then we're going to have. Okay, now we need to be careful. So we need to do alpha times alpha. It's going to be alpha square. Alpha times gamma is going to be alpha gamma, and then we have another alpha times gamma is equal to c on a, okay, and c in this case is equal to 7, so it's going to be 7/1, which is just 7. Okay, so what is going on is this. Somehow you're going to have to solve this simultaneously. Okay, because in here you have two variable, and then in here you have another two variable, and we need another expression. So we can solve it from here already. So we can make, let's say, alpha the subject and substitute it in here, for example. Okay, or we can also use the third statement. Okay, so when you multiply them together, so in this case, we're going to have alpha multiplied by alpha, which is alpha squared multiplied by gamma is equal to negative d on a. So that is going to be equal to, what is it? Negative k. Okay, so it's going to be negative k. All right, now, from here we're going to have to find the solution. All right? Okay, so what we can